Hi everybody, so today we're going to be talking to you about special triangles on the unit circle. I'm Nikki.
I'm Robert.
I'm Apashna. Has anyone ever wondered what the rat button does on their calculators? Me too! So, since this is a grade 12 advanced functions class, today's lesson will be about using the unit circle to identify trigonometric ratios of angles, specifically angles in radians.
So, we're going to talk about what a unit circle is. So I'd like you guys to just take a moment and draw what you think a unit circle is, and then we'll come back.
A few moments later.
So now that you guys have drawn a unit circle, let's talk about its actual definition. So we know that a unit circle is a circle whose center starts at the origin, which is the point 0, 0, and has a radius of 1. And we have what a unit circle looks like. As you can see, it's on the Cartesian plane. It is a circle. It is centered at the point 0, 0, which is an important point. And you can also see that there are 4 other important points on the circle. We have the point 1, 0, we have the point 0, 1, we have the point negative 1, 0, and we have the point 0, negative 1. Okay, so now we're going to look at the 2 types of special triangles that we have. And before we do that, I just wanted to talk about what an acute angle is. An acute angle is any type of angle that you have that is less than 90 degrees. So we can see for this first triangle, the acute angles are 45 degrees, and they're acute because they are less than 90 degrees. The side lengths of this triangle are both 1, and we have a hypotenuse of root 2. Now, unfortunately, on the unit circle, you can't have a hypotenuse of root 2 because it has to be of length 1. So an easy fix is to just multiply all 3 side lengths by 1 over root 2. Our other special triangle that we have has acute angles 30 and 60. The side lengths are root 3 and 1, and the hypotenuse is 2. Now again, we can't have a hypotenuse of 2 on a unit circle. We have to have a hypotenuse of 1, so we multiply all 3 sides by 1 over 2. So now we see that these are the special triangles that reflect when we have a radius of 1 on the unit circle. The hypotenuses are of length 1. We see on the special triangle with the acute angles of 45, the 2 side lengths are 1 over root 2. And on the special triangle with the acute angles of 30 and 60, we have the side lengths root 3 over 2 and 1 over 2.
So now we're going to talk about what a radian is. So a radian is an angle made by taking the radius and wrapping it around the circle. 1 radian is 180 over pi degrees, or about 57.296 degrees. It is important to note that to convert angles from degrees to radians, we multiply the degrees by pi over 180. So for example, 30 is equal to pi over 6, 40 is equal to pi over 4, and 60 is equal to pi over 3. This is a visual representation of what a radian is. We can see that the radius wraps around the circle. So now we're going to talk about coordinate notation. On the left-hand side, we have that cosine of theta is equal to x, sine of theta is equal to y. The point xy is equal to cosine of theta and sine of theta. We know this because of the diagram on the right, where we see that the adjacent side of theta is x and the opposite side of theta is y.
Okay, now we're going to be doing an example together and looking at the angle pi by 3. Here we have our angle. Now we want to look at what side lengths we would have as the adjacent length and the opposite. Because we see that the adjacent side is smaller, we know that that side length is going to be 1/2. And since this side is longer, that side length corresponds to √3/2, which is bigger than 1/2. And in polar coordinate form, we have that x equals cos pi by 3 is 1/2, which is what we found over here, and y equals sine pi by 3 is √3/2, which we have over here. Now, I just would like to add that this is a good way to get an intuitive understanding on how to find the sine and cosine values of such trig ratios, because we don't have to constantly memorize the triangles, and we can just look at which side length is smaller and which one is larger, and just use our understanding and put the corresponding values of the side lengths where they should be.
Alright, so now that you guys have learned how to find the corresponding polar coordinates of an angle, let's see if we can do it yourself. So now we're going to take a moment to find the correct coordinates of the angle 3 pi over 4. You can see that we have two diagrams up, and basically just try it yourself and see which one is the correct answer.
One eternity later.
Alright, so I hope you guys had some fun trying to figure out what the answer was. And let's see. The answer is B. The correct answer is -1/√2 and 1/√2. Now let's see why. So we have our x value as -1/√2. And the reason for that is we're in the second quadrant, so we know all x values are going to be negative. Now, we see that our y value is 1/√2, and since we are in the second quadrant, we know our y values are positive. That's why we would get the positive value. And the reason why we get 1/√2 is because we are technically working with a special triangle that has acute angles for pi over 4, so we should have the values of 1/√2. And we also have the hypotenuse of 1.
So to revisit our initial question about the rad button on the calculator, we use this when the angle measure is in radians. you should now be able to use the lesson to be able to find the trigonometric ratios of special triangles on the unit circle. This lesson is important because it will be key to your mathematical career.
And hold this.
No, just press it. Okay, stop it.
Oh yeah, it's working.
Okay, do you want me to just go?
Yeah, just go.
Okay,
We'll cut
quiet
it.
on set! Thank you.
I think I'm ready. Okay, now we're going to be doing an example together, and I need to restart. Now we're going to be doing it, and this is English.
From the diagram on the right, we can see that the adjacent side of
That's okay.